Kicking us off will be Professor Frank Tipler, our first keynote speaker. Professor Tipler is a professor of physics at Tulane University. He has written 3 books. The first one was The Anthropic Cosmological Principle, written with John Barrow, and he's sole author of 2 very famous and fairly controversial books, The Physics of Immortality and The Physics of Christianity. I came across Frank's work many years ago when I was a student, when he was instrumental in a famous debate in the SETI world called the Sagan-Tipler debate. Frank advocated the concept of von Neumann probes or self-replicating probes colonizing the galaxy very, very rapidly, as opposed to the Sagan view, which basically adopted the Copernican principle, there's nothing special about us. What Frank is going to talk to us about today is something called the universal constructor, which is kind of like a superset of the self-replicating machine. And he's going to be, I believe it's going to be fairly physicsy. He's going to be presenting a lot of new stuff that he's not presented elsewhere before. So we're greatly privileged to have him here and to talk about universal constructors. Over to you, Frank.
Thank you, Alex.
May I make one administrative announcement for a second? Very quickly, if anyone needs hearing assistance, we have some hearing assist devices available. Talk to John Trieber in the back there. He has his hand raised. And if we find people need more than we have, we'll find more. But if you need hearing assist, ask John.
Okay, as you see, I'll be talking on the ultimate energy source, the ultimate rocket, and their use in the ultimate future. I am, by profession, a global relativist. That means we study the properties of the solutions of the Einstein field equations on the largest possible scales, the entire universe, the ultimate future, and the ultimate past. For us, anything smaller than a galaxy is really too small to even notice. We are really interested on things in the humongous scale. One of the people last night at the party asked me when I was going to be talking about the ultimate energy source, am I going to talk about matter-antimatter annihilation? In a sense, I am, but really, I'm going to be talking about the energy source beyond matter-antimatter annihilation. Okay, now, in discussing these two, the ultimate energy source and the ultimate rocket, as usual, science fiction writers have gone before us and described really what they would look like. Understand that? Let us go back to the future.
I've come from the future.
Very good. Now watch this. There's 2 sequences. This is one I want you to focus on. He needs fuel. Now watch this takeoff. Remind yourself of this takeoff. You've all seen it. Watch this. Now that's the basic idea. I want 2 things I want you to come away with. The ultimate energy source, obviously, as pictured by the science fiction writers, is conversion of garbage into energy. Yeah, that's wonderful, right? Energy problem solved when we could convert garbage into energy. The ultimate rocket, you notice, he just takes off. There is no visible exhaust. In contrast to a certain Starship launched a few months ago, it does not demolish the launching pad in the process of sending out a huge exhaust. But also, the ultimate rocket, we would like to have the ultimate, allowed by the laws of physics, specific impulse, which is about 30 million seconds as opposed to this paltry few hundred seconds of the rockets which we now have in use. Okay, now let's sketch this physically. What must happen if we're to convert garbage into energy? We have a proton, and we combine the proton with the electron and get out two photons. Now, the ultimate rocket does the same thing. It starts with a proton and electron and converts it into the most useful rocket exhaust, namely a neutrino-antineutrino pair. Neutrinos and antineutrinos act so little with ordinary matter that it'll just pass straight through the launching pad or the road, as the case may be, with no damage to the road. That's what we would like for the ultimate energy source and the ultimate rocket. Now, all the cosmologists, including myself, are convinced that both of these processes are possible. Indeed, both of these processes occurred in the very early universe, because we observe out there is an excess of baryons over antibaryons, gigantically more protons than antiprotons in the universe. We look out far into the sky, we see no boundary between say an antimatter galaxy and our galaxy, which we would see by the annihilation of the particles at the boundary. We don't see that. Presumptively, as far as the evidence shows, there's nothing out there but matter. Occasional pieces of antimatter created here and there by energetic processes, but no overall matter, overall antimatter. It's overall matter instead. We cosmologists think that there had to be a process in the early universe that would generate only matter and not antimatter. We only disagree over the mechanism. I propose that what we should take seriously is the standard model of particle physics mechanism, which has been confirmed. The standard model of particle physics has been confirmed by all experiments we've been able to conduct to date. And you know, the standard model of particle physics is a theory that explains all matter except for gravitation. Standard model plus gravitation, that's it. That explains everything as far as we can tell by the current laws of physics. Okay, now whatever matter creation process you are using, we've known for decades that it has to satisfy the three Sakharov conditions. The first one, obviously, you are violating baryon and lepton number. I'm annihilating an electron, I'm annihilating a proton. In order to get two gamma rays, I'm decreasing the protons and the leptons in that one process by one each. So I'm violating the heck out of baryon and lepton number. Second, obviously, charge conjugation has to be violated because you have a process that has to prefer matter over antimatter. And a little technicality, CP also has to be violated. Number three of the Sakharov condition, you cannot have thermodynamic equilibrium in place when this process is working. Reason, equipartition theorem. The proton and the antiproton, like all antiparticle-particle pairs, they have exactly the same mass, so in thermodynamic equilibrium, you're going to get the same number of both. It doesn't matter about the other two processes. You'll still, equilibrium will force equal numbers. So, as I've said, 1 and 2 are fairly easy to satisfy. Condition 3 is really, really hard. Now, I made a proposal in a paper I published in 2005 that when you combine quantum gravity into the picture, I use the Wheeler-DeWitt equation. It's the theory of quantum gravity which is most useful for using in cosmological context, that it really forces the universe to begin at the initial singularity with the only material content of the universe being a self-dual SU2 left field. Now, I'm propose that it was everything in the universe was nothing but an SU2 left gauge field. That's one of the fundamental fields of the standard model. Okay, now here's the interesting thing. The field would be at zero temperature, and I showed, it's fairly easy to show, that that particular type of field would automatically generate the observed baryon and lepton excess. Now, it's at zero temperature, which means it's in maximum thermal disequilibrium. The interesting thing is that the basic law of quantum gravity is going to force the very early universe to be homogeneous and isotropic, which means it has to be a Friedmann-Robinson-Walker metric. And I was able to show that in such a metric, the only allowed distribution for a gauge field is the Planck distribution. In other words, if you see a Planck distribution, it could come from thermodynamic equilibrium. If you have a gauge field in thermodynamic equilibrium, it has to be a Planck field. But the geometry alone can force the gauge field to be Planckian if it's Robinson-Walker. Okay, now, for our purposes, let's suppose this is true, that the universe did begin in this process. Then reversing the process will give us the ultimate energy source and the ultimate rocket. In the details, well, I have no clue. That's why I've got a whole pile of engineers here. All I can do as a physicist is tell, here's what the physical laws allow you to do. Get out and figure out how to do it. Okay, all right. Now, first of all, we need to establish that I'm not just going off my head here. We need to establish experimentally that it's the Standard Model process that is really responsible for generating the baryon excess in the early universe. Let's make a radical proposal. Let's suppose that the universe is still in thermodynamic disequilibrium on the largest scales. Then the SU2 left field would be the background radiation, which we observe. And, of course, we observe it to be Planck, but we already know it's also Robinson-Walker, so it has to be Planck, whether it's in disequilibrium or in equilibrium. Now, according to the Standard Model of particle physics, you'll recall electromagnetism is not a fundamental force. Rather, it's a combination of the SU2 left field and a U1 field. Now, disequilibrium would mean in the very beginning that the U1 factor is missing, the U1 gauge field is missing, and it has never been added. It would have been added if the universe came into thermodynamic equilibrium. When you throw in the Higgs field interacting with these two, the bottom line is that if this proposal is true, that the initial SU2 left gauge field persisted to the current day, then the background radiation would be just like photons, except the particles making up the background radiation would not couple to right-handed quarks or leptons. That's what that little L subscript actually refers to, talking about its intrinsic interaction. Okay, now consequences of this. First, the Sunyaev-Zeldovich effect should be half of the theoretical value, because remember, Sunyaev-Zeldovich is the background radiation passing through a hot electron gas in clusters of galaxies. But this theory is true. Only half of them will interact, so you will have the Sunyaev-Zeldovich effect reduced by a factor of 2. WMAP and Planck actually saw that. Planck said, has to be indication of somewhat new physics. I said, it is new physics in one sense because we didn't expect it, but it's old physics in another sense because it's just the Standard Model of particle physics. Nature is smarter about using physical laws than human scientists, unfortunately. Okay, now also, ultra-high energy cosmic rays would be 10 times as penetrating. You look at the data, student and I have done so, and we see exactly that. But we also need a direct observation of the SU2 left field nature of the cosmic background radiation. Now, in order to build an instrument to look for this, I managed to persuade the IT billionaire Peter Thiel to give me the money to make the apparatus. Why did Peter Thiel do this? Well, he likes the idea of flying cars. This is the first step to actually build a serious flying car. Here's a picture of the apparatus. Mainly what you see here is the screens to shield the actual instrument from the background. Right here is the main instrument. It's basically a silicon plate. We'll send the CBR through this, and there will be added here, and this one it's been removed temporarily, an antenna, usual microwave antenna. And what we will see here is, because of the background radiation would only interact with a fraction of the electrons, it's a little bit more complicated than 1/2 for a matter material rather than free electrons, but you expect a greater signal than you would for photons. To be more precise, what we're doing here is sending a signal through a Fabry-Perot interferometer, and Alex mentioned a similar instrument in his talk yesterday. Now, in the top one, you see the expected signal between roughly 8 and 13 gigahertz, and the intensity of the signal is on the vertical axis. In this range, which is the range we're going to be sweeping through in our experiment, you expect to see, if it's all photon signals, to be 2 peaks and a valley right between them. On the other hand, you'll have some background from the sky. It's roughly 1/2 sky background, which of course is photons, and 1/2 CBR when you actually do the observation. A little bit more than that observationally we discovered. But when you have that mixture, here is what you expect. If my theory that I'm proposing is correct, you still see these 2 peaks here, but in between there is a little peak right between. That's the crucial difference between the standard theory up here and my proposed theory at the bottom. Now, of course, being decent experimenters, what do? We first sent a pure photon signal of the expected intensity through the instrument. And here is the result. Once again, this is the expected signal, and what we did, we just did the obvious thing. We dumped a Ecosorb, it's called. It's a material that is basically a perfect black body for the frequencies we're interested in, microwave, and a perfect absorber, of course, is a perfect emitter. So we're looking at the emitter from this, and this is what we actually saw. Once again, the location of the peaks is very close to what we predicted, and once again, we are seeing the valleys a little bit high here, but still right here. The valleys are essentially where we expected, the peaks almost exactly the same. Okay, so the instrument actually seems to work, and remember, the signal coming through at this part of the background radiation frequency range is essentially flat. That is, the intensity is essentially the same at all of these frequencies. Okay, now what did we see when we now looked at the background radiation? What I'm going to show you are 3 slides. The top one is the traditional standard theory that the background radiation is all photons. The intermediate one is, once again, the proposal that we have essentially a pure SU2 left field for the background radiation plus a mixture of sky photons, and the bottom slide will be what we actually see. Okay, so standard theory, my theory, what we actually see. Here you're seeing very strongly the middle reduced peak. Again, these are the peaks which we expect in both cases. Now, we've done this experiment about 5 times. The weather, unfortunately, has been too poor to do it more than 5 times, but we see the structure like this all 5 times. Okay, this is the first time I've ever mentioned it anywhere, the result of this. So I think we can assume that the background radiation is in fact an SU2 left field in disequilibrium. So we've got the solution to how we actually can convert matter into pure radiation, and also tells us how matter originated to start with. Now, interestingly enough, the fact that it's in disequilibrium also gives us a nice standard model only explanation for the dark matter. You know, one of the problems of cosmology is the dark matter and the dark energy. Baryonic matter, the matter which we are all familiar with, is only 5%. So we do not know officially what is 95% of the matter content of the universe. An embarrassment. But since the standard model purports to say what all matter is, it ought to be able to give us an explanation for the dark matter, right? Well, if it's in disequilibrium, the background radiation, then everyone expects the Higgs field to start at 0 amplitude and drop down to its minimum at the current stage. But if you had thermodynamic equilibrium, that vibration back and forth would be completely damped. But if it's not damped, which it wouldn't be if you have disequilibrium the whole way from then to now, then it will just be going back and forth. And we've known since the 1980s that will give us a matter field which will act only gravitationally and weakly, all the properties of the dark matter, and it will have effectively 0 pressure, which is exactly to say dark matter. That's what is meant by dark matter, 0 pressure. Okay. Now, we also have a nice explanation for the dark energy. It is a slight imbalance between the Higgs vacuum energy, which is enormous, and a positive cosmological constant, which has to be there in order to almost cancel it out, but will not quite cancel it out for reasons we'll discuss in a moment. Now let's switch off now that we've got the ultimate rocket and the ultimate energy source. Let's talk about what this means for the ultimate future. Now, everyone in this room knows that we have to eventually engage in interstellar travel. That's what we're here to work on, right? Otherwise, we are certainly, we being whatever is in the biosphere, it doesn't matter whether 100 million years ago it's humans or some other species, the whole biosphere is going to be wiped out when the sun leaves the main sequence, if not long before. We have to leave the solar system before that happens. Now remember, I'm a cosmologist. A few years means nothing to me. Billions of years now, we're talking cosmological time scales. So within a few billion years, I think it'll be far less than that. Some people in this room might actually see the launching of the first interstellar spaceship. I hope so. We will eventually have to leave this planet. The Earth is the womb of life, but you cannot remain in the womb forever. It would be death to attempt to do so. Not only that, but I'm going to argue that our descendants, to survive, must eventually leave not only this planet, colonize the galaxy, but actually engulf the entire universe and begin to control it. Now, this is the ultimate deep space probe, grabbing control of the entire universe. But the interesting thing is, we're going to have to do it, our descendants will have to do it, if we're to survive. Now, let us consider, on the basis of general physics, what must be the case if life of any sort is to go on literally forever. The first condition is that the total entropy generated by life, whenever we live and breathe, whenever we think, we're generating entropy. We all know this. But we're talking now about forever. This process goes on literally forever. We think forever. We think an infinite number of thoughts between now and the end of time. In order for an infinite number of thoughts to be thunk, if you'll pardon my bad English, you have to have the total amount of entropy generated by life between now and the end of time to be literally infinite. Here I go through the integrals, showing you what actually must be the case. Another condition The universe must allow an infinite amount of information to be stored and processed. Now, Alan said I'll be talking about the universal constructor. I am indirectly, because you actually have to construct a universal computer. And what is a universal computer? We all know what a universal computer is. We have Turing giving us the first example, universal Turing machine. It's basically a simple computer, but it's connected to unlimited memory, an infinite tape in the sense of Alan Turing, but any sort of memory will actually work. The crucial thing is it has to be literally unlimited. Okay, now, if you don't have an unlimited tape, what you'll do, even if you generate an infinite amount of entropy, is you will just have to start repeating yourself. There's a limited amount of memory. Once you've used the memory, you can just repeat. You can't go outside yourself. So, literally, to have an unlimited constructor, true universal constructor, true universal computer, you have to have a universal computer. Now, there are two barriers to constructing a universal computer. The first is the Bekenstein bound. I don't know if any non-cosmologist or black hole physicist is familiar with this, but it's extremely important. What it is, Bekenstein, a student of John Wheeler like myself, took the Heisenberg uncertainty principle, made it fully relativistic, and threw it into the language of information theory. What it says is that the maximum amount of information, computer entropy or any sort of information. Entropy is one type of information in this more general sense, but also stored information in a computer memory. It's bounded by two things. Here are the exact formula, but the crucial thing is you're looking at a sphere of radius r, and in that, coding all your information is a certain amount of energy E. The crucial thing is the product ER. If the amount of information is to diverge, then the product of ER also has to diverge. The second barrier is that there must be unlimited communication between different parts of, you can call it the computation region or the biosphere. Ultimately, from the point of view of ultimate physics, there is no difference. You must be able to send light signals back and forth between various parts of the region. Now, for light rays, we have the four-dimensional metric ds squared, and I'll just write it simplicity, the Friedman flat metric. This is 0, so we can integrate, and we find for x to diverge, that's proper distance. You're going back and forth without limit, so this integral has to diverge. There is a problem, however, if the universe accelerates forever. Right now, it's observed to be accelerating, and it's observed, as far as we can tell experimentally, it's due to a cosmological constant. Well, we got a real problem here, because if it is a cosmological constant, it will never drop below a certain value. And then you can integrate the Einstein field equations, and you find that the radius of the universe is going to expand exponentially with proper time. You put that into the integral that I showed you before, and you find that integral, unfortunately, is finite. So, if it were to continue this dark energy, its current magnitude forever, then you put in the actual numbers, which we've observed. We can compute what this lambda factor is, and we can only signal out to about 5 gigaparsecs. And in comparison to infinity, that's not very much. Okay, well, that means that the product of ER, the amount of energy available in a sphere of a mere 5 gigaparsecs, is going to be finite. So that means that the Bekenstein bound would doom life. Fortunately, I can prove that the laws of physics are actually going to require the acceleration to stop and allow a universal constructor computer to be constructed. Remember that Stephen Hawking in the 70s proved a very interesting theorem that black holes are evaporating. They're not really black. They have a very long lifetime, but they are eventually going to radiate away all of its mass. Now, the interesting thing to me, the most important result of Steve's calculation was he showed that were a black hole to evaporate to completion, it would violate a property called unitarity. Now, unitarity is actually a central law of quantum mechanics. It's really fundamental, and it cannot be violated. So, let's think of the consequences of that. If the universe were to accelerate, or more generally, to expand without limit forever, black holes would necessarily completely evaporate and therefore violate unitarity. Conclusion from this, two facts which are apparently inconsistent. How do we resolve them? There is only one way to resolve them. The universe, therefore, cannot expand forever. Total future time, in our way of measuring time, must be finite. The universe, in other words, must end in a future singularity. Now let's consider the collapse of the universe into that final singularity and apply once again this wonderful Bekenstein bounds. Wonderful when applied to cosmology, and all sorts of things become very clear when we do it. Okay, now Bekenstein, using his own bound, showed a few decades ago that if event horizons, think of event horizons as boundaries limiting communication, then as you're going into the final state, the entropy of the universe would have to approach zero into the final singularity. But you know, there's plenty of entropy around in the universe today. We're generating God knows how many joule degrees Kelvin in this room, but we're definitely generating entropy. And the second law of thermodynamics says the entropy we generate, and the rest of the universe gigantically more, would have to go to zero if they're event horizons. My conclusion is, well, the Bekenstein bound is going to tell us, combined with this results of unitarity and Hawking, that event horizons cannot exist if the second law of thermodynamics. Now, you can prove as a theorem that if there are no event horizons, then the universe must be spatially closed, and the universe has to be, a technical term, globally hyperbolic. Global hyperbolicity is the general relativistic version of unitarity. Okay, now, no event horizons guarantees that this integral will be as it has to be, infinite, unlimited communication back and forth between the universe. But the Bekenstein bound in this particular case allows us an energy source, which is a true energy source. It's actually gravitational collapse. Gravitational collapse energy is actually the true source of most of our power here. What is the source of uranium for uranium fission? The best guess now is that it's coalition between two neutron stars. We know uranium is created in some sort of R process, so the best available source of neutrons are going to be a coalition of coalescence of neutron stars. If you look at a supernova, a massive supernova, it looks like it's gravitational collapse energy. That's the source of uranium energy too. So when we are using nuclear fission, we are using really gravitational collapse energy. But the end result is that this curvature, which I show in my book, The Physics of Immortality, can actually be extracted. And I show how to extract it. It allows an energy source that is diverging over the whole universe as 1 over the radius of the universe cubed. As r goes to 0, it goes to infinity. So we multiply that energy, E, 1 over r cubed, times the radius of the universe, r, and it diverges as r squared. So yay, the Bekenstein bound also works fine in the case of a final singularity. Now I can also show, it's a little trickier to show that this integral the amount of entropy generated diverges. Reason it's tricky is because right now we are actually dumping our waste heat into interstellar space. If the space is infinite, no problem. You just continue to dump your waste heat into interstellar space, intergalactic space, into the universe as a whole. That's what life has been doing on this planet ever since life came into existence on this planet 3.5 billion years ago. In this particular case, remember, you're in operations, you're controlling the entire universe. You are manipulating the universe so that you have access to this energy source. And also, it's a little interesting point, if you look at the detailed general relativity, you're actually manipulating the universe to keep communication lines open to eliminate the event horizons. The problem with this integral is that since you're dumping heat, not elsewhere, dumping it outside, you're dumping it here inside your own room, so to speak. There is nothing outside the universe. So this is diverging more rapidly as R is going to 0 than 1 over R, which would be the adiabatic collapse. But if you look in the details, and I do that in the appendix of Physics of Mortality, this integral diverges. Okay, now I mentioned this, our descendants will actually be there at the final singularity. They have to be there in order to make sure that the universe moves in this correct way to eliminate horizons. And notice that their presence in the ultimate future is required in order to ensure the forever consistency of the second law of thermodynamics. It used to be thought that the second law of thermodynamics was our entropy. Actually, it's our friend. It's the second law that guarantees that we'll actually make it doing what we are now trying to do. We will eventually, hopefully in the near future, but eventually we are guaranteed to succeed. Okay. Now, let's go back to the elephant in the room, namely the observed acceleration. I've already showed you that if acceleration continues forever, we're doomed. We have to have a way to turn off the acceleration. But remember the experiment I showed you. It indicates that we know what the dark energy is. Now, the interesting question is, why is the positive cosmological constant, which has to be there, not precisely canceling the Higgs vacuum energy, which looks like a negative cosmological constant? Now, the interesting thing is the very process of generating this matter in the early universe, that process itself is going to slightly raise the effective Higgs vacuum energy. It's vacuum tunneling. It's generating this, so it's not surprising it's affecting the vacuum energy. Consequently, reversing the process will turn off the acceleration. Thus, by using what I've called in the early part of this talk, the ultimate energy source and the ultimate rocket, we, or our descendants, will actually be turning off the acceleration. Turning off the acceleration actually will slow down the expansion of the universe, keeping it in an almost Einstein static universe case, which allows us to move out and actually have time to engulf the universe. Originally, in my book, 1994, I predicted that there had to be an acceleration phase in universal history in order to allow us time to truly gain control of the entire universe. But this particular process, which I overlooked, unfortunately, I should have predicted the acceleration in the expanding phase of the universe. This actually works much better than the process that I proposed in the Physics of Immortality. Okay. Now, the point is, the bottom line, the biosphere will necessarily survive forever. Also, necessarily, we will create, in passing, a universal computer. If you have an unlimited memory source, then remember the Bekenstein bound says that the complexity of the universe now is limited. It's bounded above. The entire visible universe can be coded in a computer memory of 10 to the 123rd bits of information. Large number, but finite. Remember, we got infinite amount of computer power. What's 10 to the 123rd when you've got infinity? Okay, so if you have truly unlimited computation, then you can reconstruct as a perfect emulation, not a simulation, but an emulation. It's a perfect copy of the universe now. You can make a perfect copy of everyone who has ever lived. Every living being who has ever lived can be brought back into the computers as virtual reality emulations in the far future. Life, in other words, is guaranteed by physics to go on forever, and we ourselves individually will actually be there in the far future. I like to express this as saying, if the laws of physics be for us, who can be against us?
We have some time for questions if anybody has any questions.
What happens after the singularity?
The laws of physics Laws of physics tell us you can't go beyond the singularity. The singularity is the beginning, and the singularity is the end, and it encompasses all time in between. Laws of physics say you just keep going until you reach, till you can't go any further, and that's the beginning of time, which is outside of time. I'm sorry?
It doesn't repeat.
No. Laws of remember, the second law does not allow repeating. Now, many of my colleagues, for example, Roger Penrose and Stephen Hawking, they don't like this theory. But the only way, they're not stupid, they're geniuses. They know what they have to do in order to avoid this theory. They have to dump one of the fundamental laws of physics. In this case, the second law of thermodynamics. Second law of thermodynamics does not permit repetition. Now, the person who's done the most work on that is Roger Penrose in his book, The Cyclic Cosmos. That's a cyclic cosmos, of course, and he knows he has to get rid of that nasty second law. What does he do? We have to throw out unitarity, he said, and the violation of unitarity is going to get rid of the second law. Unitarity, however, follows from the law of conservation of energy, so also he has to get rid of the first law of thermodynamics too. Now, it's worse than that, because it might be that, well, experiments are not absolutely precise, so maybe we've missed a little tiny violation of the law of conservation of energy. But Lenny Susskind of Stanford University wrote a very interesting paper a few decades ago in which he showed if you have a unitarity violating process out there and it interacts with electromagnetism, everything does in the end, at least, if not tree level, then at loop level, then there is unbounded amount of energy increase. Now, he arbitrarily, with nervousness, just cut this unbounded violation at the Planck energy, but I showed in one of my papers that there's a nifty way of coupling this to a current in a ordinary electric lights currents wire. Plenty of electrons there. So I showed there's if he's right about amplification, and he is, then every time you were to flip on a light switch, if there's a unitarity violating process out there, so much energy would be created out of nothing that the earth would be blown apart. So we turn on the light switch here. We're still here. I think we can conclude unitarity is good.
No, you have to use the microphone, or you can't be recorded.
Yes. Am I on? Yeah. First of all, I really very much enjoyed your book. I'm a great fan of it. One of the physics of immortality. What bothers me is this universe, which is very possible, all of us get emulated and live on forever. And as was pointed out in a science fiction series, I think by Jose Farmer, this includes nice people like Adolf Hitler. So how do we deal with that from an ethical and moral point of view? Or are ethics completely irrelevant?
Well, I think that science has built in some ethics itself. For example, thou shalt not fake your experimental data. Now, maybe I've faked the data I've shown here. Fortunately, you can check me by going out and build the duplicate machine and making the same observation. So I'm not dumb enough to fake the data, which can be checked inside of a year. But that is a fundamental principle of science. Thou shalt not fake data. In other words, thou shalt not bear false witness. Heard that one before? Then another principle of science, it has to, remember, science is really a process. We're all working on this. We is the crucial word. We're interacting with each other. I'm persuading you, this is what the laws of physics require. I am inviting you to do the calculations yourself. This is just mathematics. The laws of physics are in the textbooks. You can do it as well as I. The point is that you must not impose your theories on other people by force. You must persuade them. You must get them all to work together rather than sticking a gun in somebody's face. Believe my theory, I'll shoot you. In other words, thou shalt not kill. You can go through this and you can deduce the entire 10 Commandments just from the principle of science. So, science itself encodes ethics. The beings in the far future, in order to succeed in this, will be vastly superior to us in physics. And since they'll be vastly superior to us in science, they must be vastly superior to us in ethics. But the basic ethics they will be using is the ethics which, roughly speaking, only unfortunately, roughly speaking, we're familiar with. Now, in the case of these unfortunate individuals like Adolf Hitler, and I suspect everyone in this room, though not as bad as Adolf Hitler, is still has some embarrassing episodes in their past that they would rather have not committed. I do not know yours, but I do know mine, and I'm hoping it will be overlooked by the beings in the far future, or at least I'm hoping that they will give me advice on what to do. And if you deny that, who knows who I will not be in charge. It will be beings with who are truly immortal and have vastly more intelligence and power than I have. It may be augmented human beings, downloaded human beings who've augmented their intelligence. Who knows? That's a detail. I'm only interested in the broad physical picture here. But what I would expect to happen is that the people who are brought back in the far future, who are pointed out, you made some very bad mistakes, and I expect you to correct that. If they refuse to correct, they will just be not allowed out into the higher levels. That's what I would expect them to do.
Frank, that was a fascinating talk. I think it's about the understatement I can make. The question I have is, you go back to your data slide of your silicon plate, and I have a...
See if I can locate it.
Yeah.
That's not on, and I'm having problems getting the slides. You go back here.
Okay.
Let's see if this works.
So, Frank, did you repeat the process with the EchoSorb at various temperatures rather than just at room temperature? Because your silicon plate is at the same temperature as the EchoSorb, then you're more or less in thermal equilibrium, unless you won't see a systematic error that would happen as the plate temperature is different than the sky temperature. So did you repeat the EchoSorb at any different temperature than the silicon plate?
No.
Okay.
So that may be a problem.
That would be a classic systematic error. I've worked in CME for 45 years. It's easy to get systematic errors, as you probably know. I would try that just to make sure, because you could easily fool yourself into getting something which is not real.
Getting a signal that's not real was something, of course, that worried me. Now, you're recommending that the silicon plate be at a different temperature than the EchoSorb?
Yes, what I would start with is, first of all, because the sky temperature 10 gigahertz is going to be at word 5 Kelvin, so
yeah,
depending on the site that you're at. And so since the silicon plate's probably at room temperature.
Well, room temperature by the standards of the background radiation, yes.
Yeah. So if you have your EchoSorb at the same temperature of the silicon plate, then it will look just like you're in a thermal equilibrium, and therefore when you rotate the plate or take off the equasorb and you're looking at the sky temperature is vastly different than plate temperature.
Oh, yes.
So I would suggest, just from an experimental point of view, repeating that just to make sure, and then plot the signal as a function of temperature differential.
All right. I think part of that has been done because I think the equasorb was taken from we basically had the silicon plate to freezing temperature. And the ecosorb, I think this was done years ago, so I can't remember off the top of my head, was taken out of a room which was closer to room temperature. So there are slight differences. They're not truly in equilibrium.
Yeah, well, anyway, just
Okay, well, I appreciate the comment.
did you publish this somewhere?
No, this is an announcement for the first time.
Oh, okay. Maybe we can talk afterwards.
Okay.
I think, well, I didn't take any questions from that side, so. Okay, it's working.
Thank you. Test, test, test. Hi, Frank. This is René Heller, Max Planck Institute for Solar System Research in Germany. Your talk made me think of the entropic principle, which, if I understand correctly, suggests that the universe has to exist in a way that we observe it, or otherwise we wouldn't be here to observe it in the first place. Now, your line of reasoning, if I understand correctly, seems to imply that also we have to be here in a way to make the universe work?
Yes. This is called teleology, and it's another way of expressing unitarity. I'm confident in quantum mechanics.
Cool. Thank you.
So I can just speak loudly.
No, we needed the microphone.
Yeah.
Pass the microphone.
Do you know Bruce Partridge?
Test.
Do you know Bruce Partridge? Okay, I figured you did. He's one of the guys on this. Okay. He would be the person to really...
So, I'm maybe not familiar enough with particle physics to understand everything you just said, but a lot of it seems to hang on this unitarity. Could you explain it to me a bit better so I understand what...
We might want to come to the blackboard afterwards.
Okay,
I'll be happy to show
that.
you. It requires the normal way of expressing unitarity in non-mathematical language is its conservation of information. And another way, if information is conserved, then you have total determinism. Now, it's a little bit more complicated because this is quantum mechanics and you have the multiverse. So what is really determined is the entire structure of the multiverse rather than the particular universe we find ourselves in. The multiverse is just automatic when you do quantum cosmology. And many worlds has, of course, been independently discovered 5 times because it's there in the mathematics. But what unitarity really is that you have a wave function now. Let's call it t is equal to 0. Then you have a time evolution operator which depends on time. And this gives you the wave function at a later time. So what unitarity is, it's the time evolution operator, and the Hamiltonian is the generator of the time evolution. It's E, if I remember correctly, U of t is, if the Hamiltonian is time independent, it's going to be t to the minus h t, as I recall, over h bar. Just integrating the Schrödinger equation. Now, you can look at this, which follows from the Schrödinger equation, and it tells you that the inverse operator to this operation is simply given by the Hermitian conjugate of your original operator. Yeah, U. This is literally what unitarity means. And what I'm doing is I am expressing some of the consequences of unitarity that have been worked out over the past few decades, rather than the original definition. But this is what it means in mathematical terms. It's not obvious that that's information conservation, but I can show you a reformulation of that in non-relativistic quantum mechanics, which is good enough for me as it happens, because the Wheeler-DeWitt equation for the radiation-dominated early universe happens to be the non-relativistic Schrödinger equation for the simple harmonic oscillator. It's fully relativistic, but it's same as the equation for non-relativistic quantum mechanics, simple harmonic oscillator, which we all know and love. But more detail I would have to go into on the blackboard.
Yeah, we don't want to go further down.
That's right.
Okay, well, thank you, Frank, for